Hello subscribers, welcome to Semantics tutorial. In this video we are going to see measures of central tendency, which is very important answer.
Measures of central tendency. So measures of central tendency is nothing but a statistical average which represents the entire distribution. So we have here five measures of central tendency. First one, arithmetic mean, median, mode, geometric mean and harmonic mean. These are the five measures of central tendency we are having. So how to write explain this answer clearly means, so this is very important long answer for exam, for theory exam. So how to write this answer? First you need to write the definition of measures of central tendency. After that there are five measures of central tendency. Okay, this is the second point. Once you have written five measures, you have to name them also. Now each one you have to explain it clearly. So first one is arithmetic mean. So for arithmetic mean you need to write the definition and the formulas related to arithmetic mean. So not only for arithmetic mean, geometric mean, harmonic mean, whether it is median or mode, you have to write the definition and the formulas based on this measures. So we have here for each method three formulas are there. So one is in case of individual series, second one in case of discrete, and third one in case of continuous series. So let's see one by one clearly. So arithmetic mean. What is arithmetic mean? Everyone knows what is arithmetic mean. We are learning since 9th class. So arithmetic mean, how we will get the arithmetic mean? It is a sum of observations divided by number of observations. So here we have, I told you, like three formulas we need to write in case of individual, discrete and continuous. So individual series comes under ungrouped data. So let's represent the formula for individual series. So generally the arithmetic mean formula is x bar equal to summation xi by n. This is sum of observations divided by number of observations. So that is what individual series is. So same formula, summation xi divided by n. This in case of individual. What is individual series? If only the observations are given, like x1, x2, x3, so on, xn, then only you have to apply this individual series. So this is first formula, individual series. Next we go for grouped data. So here next comes the grouped data. In grouped data we are having discrete series, discrete data. Next continuous series or continuous data. When to use discrete and when to use continuous. So discrete series means individual series we have already seen that if only the observations are given, like x1, x2, so on, xn, then you have to use the individual series. If when to use discrete means when observations are given, along with that frequencies are given, then you have to use a discrete series data, discrete series formula. So we have the formula as summation x bar equal to summation fi xi by summation fi, where fi represents the frequencies, xi represents the observations, summation fi represents capital N. You can also represent summation fi as capital N. So overall we got summation fi xi divided by capital N as a discrete formula. Next we are having continuous data formula. When to use continuous? So here also you will have x values and frequencies. Both will be there. What is the difference between discrete and continuous? Continuous means you will have the x values in terms of class intervals, like 10 to 20, 20 to 30. So this is the case of continuous data. And frequencies will be given directly in number 1, 2, 3. Coming to discrete, x and f, x will be in the form of 1, 2, 3, like that. Some n observations will be there, sorry, n values will be there, and frequencies according to that is 6, 7, how many times x value is repeated, that is what frequency. From in continuous data you can use any one of these two formulas, are equal to summation fi xi divided by summation fi, where xi is what, here you have to take the midpoint, because here directly x value is not given, so we have to take the midpoint. So in continuous data only we will have step deviation method. So step deviation method formula is x bar equal to a plus summation fi di by capital N into h, where what is a? A is assumed mean, di equal to deviation, di equal to xi minus a by h, and h is the length of the class interval, where xi is what? From di we are having xi minus a by h, xi is a midpoint. So this is the step deviation method. So next comes the median. So how to get the median? First step, we need to arrange the data into in ascending order or descending order. After that we need to find number of terms. Based on the number of observations we are going to get the median. So median is also known as positional average. So in order to calculate median we have three series or three cases, you can say. First one individual, second one discrete and continuous case. Let us see what is individual case. So when to use individual case? We have to use individual case when only the observations are given, only observation, not frequencies. So if the observations are given, then xi values are given. First we need to find out the median value by arranging the data in ascending or descending order. Once you have did that, we have to consider the middle term as a median. But here we are having two cases. First one is a odd case, or and first one is odd case. That means when n value, number of terms are order, then you can use this case. So same, first we need to arrange the data in ascending order, then if it is odd you have to consider n plus 1 by 2 as term as median. So when if it is even, number of terms, that is capital N value is even, then you have to calculate first n by 2 and n by 2 plus 1 value. After that you need to take the average of this value as a median. So the two cases is very different. First one odd, only n plus 1 by 2 the term you have to take as odd, not n plus 1 by 2. If we do, we'll get some answer, that is not. So you have to just consider the term as a median, and here n by 2 we have to do separately, n by 2 plus 1 we have to do, then you have to consider the average of this as a median. Next we have discrete series. So in discrete series, what we'll be having? We will be having x values and frequencies. How to calculate it? So we are having like 5 steps. First we need to calculate n. Capital N. Capital N is sum of all the frequencies, that is summation fi. Once you are done, next step, find n by 2. Whatever the n you obtain here, divide it by 2 and keep it aside. Next, third one, calculate cumulative frequency. So calculate the cumulative frequency. Next, identify the cumulative frequency more than n. So here we have calculated cumulative frequency. From that you have to take out the value, only one value which is more than n by 2. So here we are getting in step 2 n by 2. So you have to find which value from the cumulative frequency is more than n by 2, that is greater than also you can see. Next, the corresponding x value is median. Whatever the corresponding x value is there, that will be your median. Next we have continuous case. So in continuous case also we will have x values and frequencies. The formula for median in continuous case is m equal to L plus n by 2 minus Cf by f into h, where L represents the lower limit, capital N is a summation of all the frequencies, and Cf is the cumulative frequency above n by 2, f is the highest frequency, and h is the length of the class interval. So if our class intervals are given, we have to use a continuous case. Third central tendency is mode, and here the mode is calculated based on the number of times the value is repeated. So here also we will be having 3 series, individual, discrete and continuous. Let's go for individual case. So individual series, here the terms, whatever the observations are given, we are going to arrange in ascending or descending order. Then we have to check which term is repeating more number of times. So if the highest number of times the value is repeated, if any value is repeated highest number of times, that value is considered as a mode. So we can see here example, obtain the mode of the following data. First we have arranged here ascending order. So which value is repeated here? Highest number of time, 10 is repeated 2 times, 12 is repeated 4 times, 15 is repeated 2 times, 16 2, 18 1, 22 and 24 1 time. So as 12 is repeated 4 times, so now our mode is 4. Next, next we have discrete series. So here x value and f values will be given. So you have to check which frequency is highest. So if any of the frequency is highest, the corresponding x value is taken as a mode. For example, if you take this one, 1 2 3 4 5 6 7 8 values are given here and the frequencies are given. So the highest frequency is 25. Now the corresponding x value is mode. So this is a discrete series. Next we go for continuous series. Next, continuous series. Continuous series, we have a formula. Mode is represented by z. So z equal to L plus f1 minus f0 divided by 2 f1 minus f0 minus f2 into h. So here L is the lower limit, f1 is the highest frequency, f0 is the frequency preceding the model class. Again we have here f1, I have told you already, highest frequency, f0 is the frequency preceding the model class, f2 is the frequency succeeding the model class, and h is the length of the class interval. So you can see here L is the lower limit, h is the length of the class interval, f1 is the highest frequency, f0 is the above the highest frequency or frequency of the preceding model class you can take, f2 is the frequency of the succeeding model class. Next, our fourth measures of central tendency is geometric mean. So geometric mean is obtained by taking the nth root of the set of observations given. So here g equal to x1 x2 so on xn whole power 1 by n. Next, taking log on both sides. So log g equal to log of x1 x2 so on xn whole power 1 by n. Next, we know that a formula log a power n can be written as n log a. So by using that formula we have written like 1 by n log x1 x2 so on xn. Again we have a formula in log ab equal to log a plus log b. Now we can split these values. Log x1 x2 so on xn can be written as log x1 plus log x2 so on log xn. So finally you are going to get 1 by n summation I equal to 1 to n log xi. Therefore log g equal to 1 by n summation I equal to 1 to n log xi. Now applying log on both sides. So you will get g equal to log of 1 by n summation xi, which is the formula for individual series. Now comes the discrete series. So directly we will write the formula g equal to anti-log of 1 by capital N summation I equal to 1 to n fi log xi. So same here, the formula for individual and discrete is same, but what is there? We are changing log as anti-log and small n as capital N. As you already know that in discrete series along with x values frequencies also will be there. So here fi into log xi and n is the total frequency. Coming to the continuous series, continuous and discrete is completely same, but the only difference here is we consider in discrete xi as a value or observation, but here xi has a midpoint because in continuous series all the values exist in the form of
all the x values exist in the form of intervals, class intervals. So we'll take the midpoint as a x value, and you already know that n is the total frequency. That's it.
Now comes the harmonic mean, which is the last measure of central tendency. So it is obtained by taking the reciprocal of arithmetic mean of its reciprocal values. So generally we denote the harmonic mean by hm, and we calculate like this: small n by summation 1 by xi. So 1 by xl is generally how we calculate arithmetic mean, summation xi by n, but the reciprocal of that will be n by summation xi. Now for that only again we are applying reciprocal to each observation, that is 1 by xi. So n by summation xi changes to n by summation of 1 by xi. So if you substitute the values, you are going to get n by 1 by x1 plus 1 by x2 so on 1 by xn. So this formula is same for individual series also. If only x1, x2, x values are given, you can apply this formula. Coming to discrete case, you have the formula as capital N by summation fi into 1 by xi. So n by this can be written as n by summation fi by xi, which can also be written as n by f1 by x1 plus f2 by x2 plus so on fn by xn, where capital N represents the total of all the frequencies, total frequency. And continuous case also we will be having the same formula, but the only difference is where xi is a mid value or midpoint of a class interval you can take. So finally continuous series also same, only the difference is xi is a midpoint of a class interval. So harmonic mean and geometric mean will be having same formulas in individual and in discrete and continuous cases, but the only difference is here xi is a midpoint.
Hope you liked the video. Please subscribe, like and share the video. Thank you for watching.